Hey, what's going on, guys? Today we're going to be looking at 13.3, geometric probability. So geometric probability is used in situations where points on a segment or in a region of a plane represent outcomes, and it's found by calculating the ratio or a ratio of two lengths or two areas. So basically, and this is true for pretty much all of probability, it's always desired outcome over whole or all possible outcomes. So, for example one, okay, a bug lands at a random point on the ruler's edge as shown below. Find the probability that the point is between 3 and 6 inches. So, our whole length of this ruler is 9. 3 to 6 is right here. Okay, that's a total of 3 inches, right? So the desired is 3. Okay, again, so when it says between 3 to 6 inches, that's an interval. Okay, and the length of that, or the fractional part of that ruler that we're trying to see if the bug lands on, is within 3 inches out of the entire 9 inches. So again, desired over whole, 3 over 9 reduces to 1 over 3. Boom, that's it. So that's the probability that if a bug was to randomly land somewhere on the ruler, it'd be between the interval of 3 to 6. Um, let's go ahead and go to a different type. So for area, really the same thing, just desired area over total area. Okay, so example 1 says, what is the probability a dart will land on the red region? Okay, so we're assuming this whole thing's a dartboard, right? So the whole area of the dartboard, okay, will just be 16 times 16. So 16 squared, which is 256. Now, the area in question, the area that we desire, is the red circle, okay? And it gives us it has a radius of 2. So the area of that circle, pi r squared, or pi times 2 squared, goes to 4 pi. So hey, we go ahead and take that ratio of desired over whole, okay? Our desired area is that small circle, 4 pi. And then the entire area of the dartboard, and we're assuming, I guess, that every time they throw a dartboard or throw a dart at the dartboard, it'll at least land within that square, is 256. Okay, so you just put that in your calculator, 4 times pi divided by 256, and that gives you about 0.05. Okay, but it says, so it says round the decimal to the nearest hundredths, and then write as a percent. That's pretty easy. For a percent, all you do is move the decimal 2 to the right. So 0.05 is also 5%. Okay, let's go into the last type, which is angle measure. So if you have a circle, right, and it looks like this, like in example 3, all right, an entire circle, all those interior angles or central angles add up to 360 degrees. So if you want to know what's the probability of it landing within a certain sector, okay, you just take the fractional part or ratio of that central angle over total central angles for a circle is 360. Okay, so example 3, Says use the spinner below to find the probability of the pointer landing on the angle measured pointed. Leave answer as a reduced fraction. All right, so the arrow's in the yellow section, the yellow sector. Okay, so that just means we're looking at a probability of 140 over 360. So reduce this fraction, so these zeros go away. We have 14 over 36. Okay, take a 2 out. Okay, and we got 7 over 18. And it says we can leave it as a reduced fraction for so boom, that's it. So the probability of the pointer landing in yellow is 7 to 18. 7 over 18. Okay, and that is really it, guys. Thank you.